Hello students, today I'm going to talk about a very vast area, okay, which is an important part in organic chemistry, and you all face a lot of problem in this particular regard. Now, सब लोग बोलते हैं sir, how to remember all the oxidizing and reducing agents here? Okay, sir, a concrete list ho to it will be better for you. Then to remember also during the exam that which is oxidizing agent and which is the reducing agent. So in this video, what I will talk about all the possible oxidizing and reducing agents which are there in your complete organic chemistry syllabus for NEET. Okay, and before the exam you just have to revise this all list, okay, and make sure that you write correctly in the exam. Okay, so ye video last tak dekhna, all of you, and at the end of the video what you will learning, the take home message will be that you will be having all the crisp part of the oxidizing and the reducing agents, and where to apply, what to apply, or कौन से reaction में you have to use what reagent, which oxidizing agent and which reducing agent, where I will completely discuss. So basically I am going to give you a whole list on this video. Now see, fundamentally if you see that there is something, whole thing is going on by a reaction. If I think that starting from your hydrocarbon, let's say a carbon hydrogen compound, a simple hydrocarbon compound, if I think, then beta, one thing is for clear is that if you oxidize this hydrocarbon, you will be getting alcohol. You will be getting alcohol. If you oxidize this alcohol, you will be getting carbonyl compounds. You will be getting carbonyl compounds. Okay, and if you oxidize this carbonyl compound, you will be getting your carboxylic acid. You will be getting the carboxylic acid. Now beta, if you further oxidize the carboxylic acid, you will be getting carbon dioxide. Now many of you know one thing, which is okay, if I direct oxidize the hydrocarbon to carbon dioxide, we can do a direct oxidation, and we know this oxidation step is known as the combustion. That is why remember always that combustion is called ultimate oxidation. Combustion is called ultimate oxidation. Okay, so further if I go backwards, then if you reduce the carboxylic acid, you will get carbonyl. If you reduce the carbonyl, you will be getting alcohol, and if you reduce the alcohol, you will be getting hydrocarbon. So this is basically known as the central part or the central idea about the oxidation and reduction in the organic chemistry. Now we will talk about each stepwise, and our job is basically will be to fill up these points. Fill up these points, that what type of oxidizing agents and reducing agents we will be implying. Now in between, let's say there will be some cases where you will find that we can directly jump from one point to another point, or we can easily go from carbonyl to hydrocarbon. We can easily go from carboxylic acid to hydrocarbon. They are there. So it is basically an interlinked thing. Okay. Now coming to the point is that the first we will talk about the reducing agents. So beta, all of you should make a heading, the reducing agents. Reducing agents. Now how we are going to talk here is basically via your overall whole your reagent wise, and also how to put this reagent in different functions. Okay, so pehla wala function jo dekhte hain, number 1 is your conversion of a carbonyl group to a alkane. Conversion of a carbonyl group to an alkane, and the reagent which is we can use, we know that all of you, that is your zinc mercury HCl, zinc mercury in presence of concentrated HCl, which is known as the Clemmensen reduction. We can also use number B, your hydrazine in alkaline medium, hydrazine in alkaline medium, Okay, and this is known as your Wolff-Kishner reduction. And also, okay, and we can also here use one thing, that is number C, that is HI in presence of red phosphorus. HI in presence of red phosphorus. So this is one of the three reagents which we can use directly to convert a carbonyl group to a aliphatic group. Now number two. Okay. Number two is what? Number two is basically you have to control this carbonyl group, reduction of the carbonyl group to the CHOH, that is your alcohol group. But somehow we have to control this reaction. So in order to do that, there are a lot of reagents we can use. So few specific reagents I am mentioning here. That is number one, that is your simple hydrogen nickel. Okay, simple hydrogen nickel. Okay, second, what we can use nickel, or we can use palladium also, but better to use nickel than palladium because reactivity of the palladium is not that much compared to the nickel. Okay, now what else we can use? We can also use LiAlH4, lithium aluminum hydride also we can use. We can use sodium borohydride, NaBH4 also we can use. Okay, and also what we can use, number D, we can use B2H6 diborane we can use, and number E, we can also use sodium in presence of an alcohol. Sodium in presence of alcohol we can use. Okay, so this is what the reagents of these two cases. Now coming to the third case, case number 3, that is the conversion of a carboxylic acid to the alcohol. How we can convert a carboxylic acid to basically an alcohol. Now beta, here the reagents which is required to use is number A, that is lithium aluminum hydride. But remember one thing, sodium borohydride do not work here. So what I will use here, lithium aluminum hydride. Okay, number B, what we will use here, other than we use H2 in ruthenium dioxide, hydrogen in presence of Ru2O, that is ruthenium dioxide, and Ru2O3. And number C, what we can use is that is hydrogen in ruthenium carbonate. Now remember this thing is that, but in principle, when we do the reaction, when we have to use a convenient or let's say a proper reagent to do the reaction, we always use lithium aluminum hydride as a reagent to convert a carboxylic acid to the alcohol. Now next part, number 4, let's talk about number 4. In number 4, we will convert an ester molecule to the alcohol, that is COOR2 will convert into CH2OH. And beta, the reagents which we will use here, those reagents which is used here, number 1, lithium aluminum hydride. Remember, lithium aluminum hydride. Okay, now number B, what we will use here, B2H6, but this is not a proper reagent, क्योंकि B2H6 जब react करता है, that reaction is very slow reaction. What we can use here, number C, और हम क्या use करते हैं यहाँ पे, hydrogen in copper chromate. Hydrogen in copper chromite. Okay, hydrogen in presence of copper chromite. Okay, and number D, there is another reagent also जो हम use करते हैं, that is your, okay, now DiBAlH, that we know that it is known as the diisobutyl lithium hydride. But remember always, this is not a reagent to convert an ester to alcohol. But if you use diol H, in this ester will be converted into the corresponding aldehydes. Okay, so remember diol H is used to convert an ester molecule to an aldehyde molecule. This is always to remember. Okay, next number 5. Number 5 क्या है देखते हैं. Number 5 is basically your, let's coming to the hydrocarbon section. तो वहां पे क्या है, C triple bonded C and we are converting into C double bonded C. Okay, so the reagents what we are using here, number A, which we will use, that is a very simple nickel hydrogen. But remember one thing here, the nickel which is used, it is basically Ni2B. Okay, or instead of the direct nickel, because if you use direct hydrogen nickel, it will be direct convert this one into the alkane. Okay, so better to avoid that. If you want to control the reaction, we use hydrogen in presence of Ni2B. Number B, we know sodium in liquid ammonia. It's a very beautiful reagent. Sodium in liquid ammonia. This is known as the Bartsch reduction also. But the thing is that if you are using sodium and liquid ammonia, remember bachcho, one note is that here there should not be a terminal alkyne. There should not be a terminal alkyne, because then what will happen, this will behave as a base and it will form the corresponding anion. So दिक्कत हो जाएगा. अच्छा, next reagent what is basically used, we can use also number C, that is known as the your Lindlar's catalyst, that is hydrogen PD CaCO3, and this is known as the Lindlar's catalyst or LCB writing here. Correct? So this is the way to convert a triple bond to a double bond. Now next method. Next में देखते हैं क्या है. In next case that will be your number 6. Sixth method. ये यहाँ पे what we will see, we will convert the RX. We will convert the RX to RH, and we know as the removal of the electronegative element and addition of hydrogen, that is also called a reduction process, right? So यहाँ पे the reagents what we will use for this one is number A. Okay, that is lithium aluminium hydride. That is lithium aluminium hydride. But remember always, this only used for 1 degree and beta 2 degree halides. 1 degree and 2 degree halides for only we can use this one. Okay, number 2 we can use, but safely we can use NaBH4. Okay, sodium borohydride we can safely use. Acha, then what we can use, there is another also reagent, that is zinc in presence of acetic acid. Zinc in presence of acetic acid, this is also one of the reagent we can use also. Acha, and fine, that's it. Then next part, number 7. Number 7 what we can do, we have to convert now in the nitro group to amine group. That is aliphatic nitro I am talking about here. RNO2 से हम क्या convert करेंगे, RNH2. Okay, and beta यहाँ पे your reagents which is generally used, we know that it is SnHCl, tin HCl. Okay, tin in presence of HCl, and this is known as the Stephen reduction. This is known as our favorite Stephen's reduction. Stephen's reduction. Then what we will use here, what else also we can use, we can also use your hydrogen nickel, also we can use hydrogen nickel, or beta we can use simple palladium we can use. Okay, what else also we can use here, we can also use lithium aluminium hydride. So one thing is clear, that in this context there are few standard oxidizing agent and reducing agents like hydrogen nickel, lithium aluminum hydride, sodium borohydride. Okay, then beta sodium liquid ammonia, in this case lithium aluminum hydride, B2H6. so they are very pretty standard reducing agents, okay, जो vastly used होता है. अच्छा, now coming to the next part, okay, number 7 की जगह होगा यहाँ पे number 8. There is another also the last thing, that is if you have a aromatic nitro group, then how you can convert that aromatic nitro group to the aromatic amine group. Aromatic nitro group to your aromatic amine group. Okay, now in this case the reagents, we know that the standard reagents what we can use, that is your SnHCl. Standard reagent we can use SnHCl. Okay, that is your Stephen reduction. Acha, what else also we can incorporate here? We can also incorporate here the lithium aluminum hydride. Lithium aluminum hydride. But beta, remember one thing, एक problem हो जाता है यहाँ पे. The problem is that whenever you add lithium aluminum hydride, the 2 nitro group, although it gets reduced, but the problem is that it actually forms this kind of compound. Okay, so azo type of compound actually form like this if you use lithium aluminum hydride. So whenever you are converting a nitro group to this kind of system, azo kind of system, you will simply use lithium aluminum hydride. Okay, acha, then if I use iron in presence of steam, then also the problem we get nitrosobenzene. That is, the nitro group is reduced to NO. The nitro group reduces to NO. Okay, then what we can do? Then this also here we can accompanied by your H2Ni. H2Ni also we can use to convert a nitro group to the NH2 group. Okay, acha. Now the last thing here, which is there are other methods also there, like electrolytic method is there, then your electrolytic reduction is there, glucose sodium hydroxide is there, right? Glucose sodium. So there are a lot of methods are there, but most important methods are like this. So generally when you convert a nitro to amine, always you should prefer SnHCl, that is a Stephen reduction. So here I don't want to emphasize or create more point here. Now the last thing, that is for the cyanides. For the cyanides, what we will do, that is RCN. So what are the ways to reduce a cyanide? Now remember always there are very fundamental way to do, that is number 1 is your simply lithium aluminum hydride. Is simply if I use lithium aluminum hydride, okay, so this will directly convert this one to your RCH2NH2. RCH2NH2, that is the primary amine. Okay, then similarly what here we can use also? Here also we can use sodium in presence of alcohol. Sodium in presence of alcohol also we can use. Number B, or what also we can use? Here also we can use hydrogen nickel, which is generally the preferred used the reagent for a conversion of a cyanide to the nitro group. And also finally, if we use this dibyl H here, that is diisobutyl lithium hydride, if I use dibyl H here in nitro group, in as cyanide group, what we will end up? We will end up by getting RCHO. It will convert into the direct aldehyde group. So this was your overall the part of the reducing agents. Okay, now let's come into the rest part of this video, that is the oxidizing agent. जो लोग थक गए हो, don't worry, you can pause the video here, or what you can do, you can just write the everything, go through everything. then take a rest, and then coming into the next part. Okay, chalo next part हम देखते हैं यहाँ पे the list of oxidizing agents that is used. Chalo next part. So let me give you a heading here, the oxidizing agents. The oxidizing agents. Okay, now in oxidizing agent also we will talk about the each different functions of the reactions. So पहले हम देखते हैं conversion of the simple conversion of the alcohol of an alcohol to beta and aldehyde. Alcohol to an aldehyde. This is a very beautiful where we know that there are a lot of reagents are there. Let me summarize the all reagents here. पहला वाला जो use होता है, we know that PCC. Full form is your pyridinium chlorochromate. Pyridinium chlorochromate. Acha. Number B, what we can use? We can also use your PDC. PDC. Okay. Number C, what we can use? We can use CrO3. CrO3 in pyridine. CrO3 in pyridine. Number D, what we can use? We can use CrO3 in pyridine, but provided it should be in DCM solvent. CrO3 in pyridine, I'm just continuing this one, in CH2Cl2 dichloromethane solvent. And lastly, also very important, we use that is copper in 300 degrees Celsius temperature. Okay, so this is one of the way to do. Acha, next point dekhte hain, next conversion number 2. Okay, now what is the number 2 conversion? The number 2 conversion is your direct converting an alcohol to an carboxylic acid. Direct converting an alcohol to your carboxylic acid. Carboxylic acid. Okay, now what are the ways to do? Now we know that there are this is, this step actually when I convert a primary alcohol to a carboxylic acid, this is for oxidizing reagent. This is a very simple, for them it is very simple. Okay, so we know that definitely our in acidic medium MnO4 minus, or we know that acidic KMnO4, or we know that alkaline KMnO4 is a very good agent. Number B also what we can use in presence of acidic medium Cr2O7 2 minus, that is dichromate medium, potassium dichromate in acidic medium. And also what we can use dilute nitric acid for this conversion. It's a very convenient way to use the dilute nitric acid conversion. Okay, now next part. Okay, now number 3, conversion of a double bond to the corresponding epoxide. Conversion of a double bond to the corresponding epoxide. And in this case what we use, a very beautiful reagent, that is MCPBA. Full form is metachloroparbenzoic acid. Let me draw the structure here. Metachloroparbenzoic acid. Okay, metachloroparbenzoic acid. Okay, what else? What also we can use here? We can also use silver oxide. We can also use silver in presence of oxygen, that actually will convert into the silver oxide. Silver in presence of oxygen also we can use, right? So these are the 2 convenient methods. Okay, now in the 4th part, what are the ways to oxidize a carbon-carbon double bond? Now beta, this is a hydrocarbon. Okay, now if you look at here, the hydrocarbon is present at the ekdam initial part. That means you cannot reduce a hydrocarbon, but a hydrocarbon can be easily oxidized to any of the component, alcohol, carbonyl and carboxylic acids, or even carbon dioxide also. Okay, so there will be a few lot of reagents here, important reagents for the conversion of this your C double bonded O, C double bonded C to different reagents, right? So let's pick up one of the method here, one of the thing here. First, if you want to convert this C double bonded C to your OH here and hydroxyl here, right? So what reagent we can use here? A series of reagent also we can use. So what we can use here, this is beta very important here. We can here use dilute cold alkaline KMNO4, dilute cold alkaline KMNO4. Or what we can use, we can also use osmium tetroxide. We can also use osmium tetroxide. And number 3 also we can use a par acid, that is HCO3H. But thing is that, remember always beta, this is a very important thing, is that these two reagent, that is dilute cold alkaline KMNO4 and osmium tetroxide, that gives you beta syn product, that is the 2 OH will be in the same side, but beta this guy, that is par acid, gives you anti product, that is these two groups will be in the opposite side. These two group will be in the opposite side. Okay, so this is a very, very important piece of information for the different problems you face. Acha, then what also we can use? We can use also here in this case the what will happen if I use the hot alkaline KMNO4? Okay, then what will happen if you use hot alkaline KMNO4? Then beta simply kya hoga? Let me show you what actually will happen. If you use hot alkaline KMNO4, then it will directly break from here. It will directly break from here. And if there is a slight chance of hydrogen present here, what will happen? This will be directly converted into 2 molecules of carboxylic acid. 2 molecules of carboxylic acid. But the point is that if I have this kind of system, that is, in one case there is this one, and there is a hydrogen here, and there is a methyl here. Now here, let's say I am using a reagent, that is the hot alkaline KMNO4, that is the hot alkaline KMNO4. Then beta yahan pe bhi this one will break from here. But since there is no oxidizable hydrogen present here, this will simply be converted into the carbonyl ketone compound, and this one will be simply converted into the aldehyde and then further oxidized to the acid. Okay, so this is a very, very, very important point which I am trying to mention. Okay, fine, that's it. And there is another way also, another thing also which we usually skip or ignore, that is this molecule. If I want to convert into, let's say, this one, and this thing we also know it is called the ozonide. This is also called the ozonide, and this is done in presence of simple molecular ozone. Now remember always beta, ozone is also an oxidizing agent. Ozone is also a very important oxidizing agent. Okay, and further also, if I use here zinc water, then beta what will happen? This guy will break from here, and finally the product jo hame milega, that is 2 molecules of the carbonyl group. 2 molecules of the carbonyl group. That means here also what we are doing, we are converting a carbon-carbon double bond to a carbon-oxygen double bond. So this is also an oxidation. So ozone is also an oxidizing agent. This is very important. Fine. So this actually concludes your all the list of oxidizing agent and reducing agents which we use in the organic chemistry. Fine. So this was the complete thing. So starting from, if I look at the how to convert the reducing agents, that is the carbonyl to hydrocarbon, then your carbonyl to alcohol, carboxylic acid to alcohol, triple bond to double bond, and single bond also. Triple bond to single bond, let me mention here one thing here, that is if I use a simple H2Ni or H2PD, I will get a simple carbon-carbon single bond, right? And also dibyl H, we use that selectively the ester molecule only convert the dibyl. If you use dibyl, it will convert into the aldehyde. Similarly, also here the cyanide, if you use dibyl, if you will go to the corresponding aldehyde. X2H, lithium aluminum hydride, sodium borohydride, lithium aluminum, there is a restriction. And then nitro 2 NH2, simple significant way is your the using the Stephen reduction. Or better last में oxidizing agents list if you see, alcohol to aldehyde, alcohol to carboxylic acid, and better finally your double bonded system, because it's also a hydrocarbon system, to the corresponding epoxide, to the corresponding alcohol, and finally to the corresponding aldehyde and the your acid. Fine. So this was the complete list of the oxidizing agent and the reducing agent in one shot. Hope you have watched the video till the end and you have liked the video, because this information, this video and this documents is going to help you a lot in your final examination. So from my side, if you have any kind of comments, any suggestion, or if I missed any oxidizing agent or reducing agent, feel free. And if you have any query, also feel free to write in the comment section. So like this video, share with your friends, and from my side and the PrepMed team, thank you everyone. Take care. Bye.